What's up, everybody? I'm sure you're crazy excited to learn about all of these triangle similarity theorems, so let's get right to it. Here we go. So if we're looking at our first similarity theorem is the angle. Ooh, what do I got, a spray paint can? I clicked on the wrong button. There we go, let's use that. So we got an angle similarity theorem, and all that is saying is that if we have two congruent angles between two triangles, so we'll use our geometry notation. So if both of those angles are congruent between these two triangles, then the triangles must be similar. And I think that makes a lot of sense because if we think about it, all the angles, the interior angles of a triangle must add up to 180 degrees. So if they add to 180 degrees, that means by giving two congruent triangles, we actually know that the third angle must also be congruent. Hopefully that makes sense to everyone. Because all three add up to 180, this final angle must be the same for both triangles. So these angles are the same. And if all three angles are the same, then we know that all three sides must be proportional. The only way to make two triangles that have three angles that are congruent is for them to be similar, which doesn't mean that they're the same size. They don't have to be the same triangle, right? But they have to be dilations of each other. So some factor k, I'll use a new color. So some factor, so this triangle, big triangle, multiplied by some factor k will give us the lengths of all of these sides. So if this side was side x, this side would be k times x. And so on. If this was y, this side would be k times y. So all we need to prove that two triangles are similar is two congruent angles. Two congruent angles. All right, let's move on to the next theorem. The side-side-side similarity theorem. You guessed it. This just means that if all three sides are proportional, then the triangles must be similar. So again, if there's some factor k, so if we call this side x, side y, and side z, and there is some factor k, or we could think about it like this. If we make this side a, b, c, the proportions, and when we say proportions, we mean like a ratio. So if we said x, let's change our color. Erase that. Let's go green. I like green. So if we said x, oh, green didn't show up. Where are you, green? Oh, it's because I have the eraser still. X divided by a, because x and a are corresponding sides. I hope everyone can see that. X corresponds to a. That should be equal to b. Oh, excuse me. That should be equal to y over b, which should be equal to z over c. So hopefully everyone's seeing that. These mesh up, right? Let's use a different color here. Purple. So z, and c mesh up. And by mesh up, I mean they're corresponding. They represent the same side. Even though they're scaled factors of each other, they represent the same side. And then y and b. So these ratios must all be equal. They must be equal to some factor k. And k is our dilation factor. So let's take a look at an example problem. It says find the value of x that makes triangle ABC similar. And remember, this is our little similarity snake. This little crazy symbol, right? That's a similar. That means a triangle ABC similar to triangle DEF. So we need to find the value of x that makes these two triangles similar. So basically all we have to realize is that the ratio between corresponding sides must be equal. So if we set that up, let's go back to purple. We can say that 4 and 12 are corresponding sides. So 4, we could say 4 is to 12, or 4 over 12, must be equal to x minus 1 So that's this side, x minus 1. I'll do it in a different color. Oh, maybe I won't do it in a different color. Switch colors. So x minus 1 over 18. And that is equal to, why is it not switching colors for me? That is equal to 8 over 3 times the quantity x plus 1. That's not the greatest looking handwriting, but bear with me, that's a 3. So all we have to do now is solve for x, right? We could solve using this, just these two ratios, right? And we could cross multiply here to solve for x. So we'd be left, if we want to work this out, we'd be left with 4 times 18 is equal to 12. Now be careful here, 12 times the quantity x minus 1, so we're going to have to distribute that 12 to both of those terms. 4 times 18 is 72. You might need to punch that into your calculator, but I think you can see that. 4 times 18 is 72. And then this side is just going to be 12x, and don't forget this, minus 12. Right? We have distributed that 12 to both of these terms. Okay, if we add 12 to both sides, we're left with 84 equals 12x, and dividing both sides by 12, we have x equals 7. X equals 7. So then I would want to plug this 7 in here to make sure that, to check our answer, to make sure this proportion holds true. So hopefully everyone can see that by using the side similarity theorem, we are able to solve for x because we know these proportions must all be equal. All right, last but not least, I know this is a long video, sorry. We got the side angle side similarity theorem. So this says if an angle of one triangle is congruent to an angle of a second triangle and the lengths of the sides, including these angles, are proportional, then the triangles are similar. Let's see what the heck that means. I forgot to draw my triangles here. So there's one triangle, and we'll call this one a proportional triangle. Okay, so all that means is if we have, let's go back to purple. If we have one side, so this side, x is proportional to this side, and we'll call that x prime. So those are proportional to each other. And then an angle is congruent, so we'll call this angle congruent to this angle. And then another side. And it's very important that we see that the sides include this angle. So they're on either sides of this angle. If that makes sense to everyone. It couldn't be this side. That would be side angle. This is side, angle, side. So the angle is included is what we say. It's in between our two sides. So if this is the case, then we can prove that the two triangles must in fact be similar. And let's take a look at an example problem that'll illustrate this relationship. So if this problem is asking me, are these two triangles similar? So I'm going to check it out. We see that they do in fact share a common angle, 112 degrees. And now we need to check to see if there is a proportion, if there's an equal proportion between our two sets of sides. Now this problem I purposely threw in there because it's a little bit tricky. We have to realize that this length LJ is our long side, our long bottom side here, and that corresponds to this 18. So this length 24 corresponds to 18. So you kind of have to rotate this triangle around to see how that fits on top of the other triangle. So it has the same orientation. So that ratio would be 24 over 18, and that must be equal to our other ratio here, which would be 10 over 8, right? Those are our other corresponding sides. So 10 over 8. So if this in fact is true, if these ratios are equivalent, then we know for sure that by side angle side theorem we can prove these two triangles are in fact similar. So let's work this out. So we can cross multiply again. I'll change colors. Cross multiply. So we cross multiply. We have 10 times 18, or 180, equals 8 times 24, or 120. and 92. Uh-oh. Those are not the same number. These proportions are not equal. Therefore, there is no k. These are not equal to some dilation factor, and thus these two triangles are not similar. So we got to be really careful. We can't just assume that we're always given similar triangles, right? Sometimes we want to test out if our triangles are in fact similar. So these are three theorems: the angle-angle theorem, the side-side-side theorem, and the side-angle-side theorem. So I can write those up so we can remember them. We got angle, angle. Those are two A's. Beautiful looking A's, Chris. Side, 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 and last but not least, side, angle, side. So if we can prove, and remember these sides mean proportionate sides, right? Anywhere there's an S, we're looking for a proportion, a constant proportion or dilation factor, and then the angles must be congruent. So by using these three different theorems, we can prove beyond any doubt that two triangles are or are not similar. All right, take it easy.